Welcome to my new video. Today my discussion on the topic of equivalent weight of some reductant and oxidant. Clear? Now the equivalent weight or the mass of some reductant and oxidant. Okay? Now what is the reductant? What is called reductant? Reductant reduces any substances. Okay? It can reduce any other substance by the donation of electron. Clear? Donation of electron. They are called the reductant. Clear? Say for example of some reductant that is more salt. Clear? What is the more salt? More salt, the chemical name of the more salt is ammonium ferrous sulfate. This is the double salt. Okay? It contains ammonium sulfate and ferrous sulfate, and there is hexahydrate that have 6H2O. So this is the ammonium sulfate NH4 whole twice SO4 FeSO4, and there is 6H2O. Another reducing agent is sodium thiosulphate, that is Na2H2O3. This is called sodium thiosulphate. Another one is oxalic acid. Oxalic acid, that means this is the structure of oxalic acid, COOH, and this is dihydrate. Okay, so they are the reducing agent. Clear? And what is the oxidant? What is oxidant? Oxidant can oxidize any other substances by removing the electron from the other substances. Clear? So it can oxidize any substance by taking electron from the other substance. Clear? So what is the example of the oxidant? That is very important, very useful oxidant for the daily titration or in your practical class. That means KMnO4. KMnO4 means potassium permanganate. Okay, potassium permanganate. And the another one is, that is K2Cr2O7, potassium dichromate. Clear? Clear? So these two are the very well known oxidizing agent. Today my topic, how to calculate the equivalent weight. So for the redox titration or any other titration, equivalent weight is very important. Okay, we know that any reaction can take place by the equivalent amount. Clear? Now my first example is, that is KMnO4. Okay, the color of the KMNO4 is purple, just like that. Clear? So, MnO4 minus can be reduced in various types of form that depends on the medium. That means whether the reaction medium is acidic, neutral or alkaline. Clear? In acidic medium, MnO4 minus is reduced to Mn2 plus, like that. MnO4 minus is reduced to Mn2 plus. Clear? So here, by balancing this equation by the ion electron method, then we get, in this process there is 5 electron transfer. Okay, MnO4 minus is reduced to the Mn2 plus. Here the oxidation number is Mn is plus 7, so the change of the oxidation state is 5. So here 5 electron is required. Clear? So what is the equivalent weight? That means equivalent weight of KMnO4 in acidic medium, that is molecular weight of KMnO4 divided by 5. Okay, according to the definition of the equivalent weight, we know if we divide the molecular weight by the number of electron transfer, then we get the equivalent weight. So this is the in the acidic medium. My next example is the reduction of KMnO4 reduction at neutral medium. Okay, in the neutral medium, KMnO4 minus, that means MnO4 minus is reduced to MnO2. After balancing the reaction, we get just like that, and there is 4 OH minus. Clear? So in this process, we can see that there is 3 electron transfer takes place. Here 3 electron transfer. So here the equivalent weight of KMnO4 in neutral medium is molecular weight of KMnO4 by 3, because here the number of electron transfer is 3. Next, reduction of KMnO4 in alkaline medium. Okay, what happened here? MnO4 minus that converted to MnO4 2 minus. So here 1 electron is required for the reduction. So here also the equivalent weight of KMnO4, that is in the basic medium, alkaline medium, that is molecular weight is divided by 1, because here the number of electron transfer is 1. So we can say that the reduction of the KMnO4 is very important. That depends on the medium of the solution. That depends on the reaction medium. Okay, in acidic medium we can divide it by 5. In neutral medium we can divide it by 3, and in the alkaline medium we can divide it by 1. Clear? And the next one is reduction of K2Cr2O7. That means here the main ion is the Cr2O7 2 minus. So here what is the redox reaction? For the what is the reduction process of the dichromate? Dichromate is converted to the green color chromium 3 plus. Clear? Now after the balancing the equation, then we get there is 7H2O and there 14H plus is required in the reaction medium, and there is 6 electron. So here the chromium 6 is reduced to chromium 3. Clear? So here 6 electron transfer takes place. So here the equivalent weight of Cr2O7, that is K2Cr2O7, that is molecular weight is divided by 6, because here 6 electron transfer takes place. Clear? Now these are the oxidizing agent. Okay. Now I discuss the equivalent weight of some reducing agent, reductant. Okay, that means the oxidation reductant itself oxidize. Okay, ঠিক আছে, oxidation of oxalic acid. Clear? Oxalic acid means COOH, and there is 2H2O. This is dihydrate. So here the number of replaceable hydrogen is 2. So we can divide the molecular weight of the oxalic acid by 2. Okay. Another we can say, that means for the redox reaction, what happened? C2O4 2 minus is converted to the carbon dioxide, and here also 2 electron transfer takes place. Okay, 2 electron transfer. So the equivalent weight of the oxalic acid is, that is equivalent weight of H2C2O4, that is molecular weight by 2. Clear? Many students can give the wrong answer about the reduction of the sodium thiosulphate. Okay, sodium thiosulphate is used for the iodometric titration, for the estimation of iodine. Okay, so you can use sodium thiosulphate for the estimation of copper 2 plus iodometrically. Okay, what is the iodometrically? If you know about the iodometrically, you can comment in the to my comment box. Okay, about the, if you know about the iodometric titration, you can comment this one in the comment box. Okay, so that means the oxidation of sodium thiosulphate, that is Na2H2O3. So here H2O3 2 minus, that is the thiosulphate ion, which is converted to the S4O6 2 minus. So here 2 molecule of the H2O3 2 minus is required for the oxidation of sodium thiosulphate. So here 4 electron is there. So to balance the reaction, we have to add 2 electron in the right hand side. So in this reaction 2 electron transfer takes place. Many students give the wrong answer because they do the equivalent weight of Na2H2O3, Na2H2O3 is molecular weight is divided by 2, but this is wrong. Okay, this is not correct. This is not correct. Okay, now what happened? Because here two molecules of sodium thiosulphate is oxidized to the S4O6 2 minus, and for the 2 thiosulphate ion, there is electron transfer is 2, but for the 1 thiosulfate ion there is electron transfer is 1. So the correct one is the equivalent weight of Na2H2O3 is molecular weight divided by 1. Clear? This is the correct answer. Many of the students give the wrong answer for the equivalent weight of the sodium thiosulfate. This is very important. And the next one is equivalent weight of the more salt. So we know what is the chemical formula of more salt? Ammonium ferrous sulfate. So here now the oxidation of more salt. Clear? More salt means ammonium ion is there, Fe2 plus is there, and SO4 2 minus is there, and there is some H2, 6H2 is there. Clear? Now here more salt means ferrous, that have the ferrous ion. So ferrous ion is oxidized to the ferric ion. Okay? Many of the students give the wrong answer because they say that here the iron is +2 oxidation state. So we can write the equivalent weight of more salt is molecular weight is divided by 2. But this is wrong. This is wrong. This is wrong. This is not correct. Clear? This is not correct. This is the reductant. Okay? So more salt itself oxidized. Clear? And Fe2 plus go to the Fe3 plus. So ferrous go to the ferric. Here the number of electron transfer is 1. Just like that. Fe2 plus that goes to Fe3 plus, and there is 1 electron transfer. Okay. Now there is 1 electron transfer. This is very, very important. So the equivalent weight of more salt is molecular weight divided by 1. Clear? Molecular weight is divided by 1. Thank you.